Hello friends and welcome to the data structures. So in today's video, we'll be covering the post-order tree traversal algorithm and the level order tree traversal algorithm. So now I'll start by giving a basic introduction of what is traversing a binary tree. So traversing a binary tree is the process of visiting each node in the tree exactly once in a systematic way. Traversing a binary tree is done because since tree is a non-linear data structure in which the elements can be traversed in many different ways, and there are different algorithms for tree traversal. So here is a list of what are the different types of tree traversal algorithms. So in the previous video, we have covered the pre-order traversal and the in-order traversal. There is a link in the description below, as well as there is a floating link on your screen which can be clicked to watch the previous video from this channel, which covered the pre-order and in-order traversals. So in today's video, we will be covering the post-order traversal and the level order traversal. So this is an example of which we'll be using to cover the post-order and level order traversal algorithms. This is the same example which we have used earlier for pre-order as well as in-order traversals. So I've used the same example since it will be easier for you to notice the differences in the tree traversal list. Now, the three steps in post-order traversal algorithm are as follows. First, we need to traverse the left subtree, then we will traverse the right subtree, and finally we'll be visiting the root node. So now let's begin step by step. So as I've stated in my previous slide, the first step is to traverse the left subtree. So we'll move down until we reach the leaf node of the tree. So now we have reached the leaf node G, which is the leftmost node in the given tree. So we'll insert G into the array, and this will be a first node which we have visited in the tree. Next, the video states that the second step of the algorithm is we need to move and traverse the right subtree or the right node in the tree. So since after G, H is the right node in the tree, we'll traverse H and insert H into the array. So here it is, we have inserted H into the array. Now the next step is to traverse the root node. So finally, for the subtree of D, G and H, since D is the root node, the next node to be inserted into the array will be D, and thus we have inserted D into the array. Now coming to the subtree of B. Now since we have traversed the entire left subtree of B, we'll now move to the right subtree. Now if you go down to the leaf node in the right subtree, there is no left child to E, hence we'll directly move to I as the right child node of E, and hence we'll insert I into the array. This is done because since we are moving down, if E had any left child, we would have inserted it into the array. But since E does not have any left child, we'll directly insert the right child into the array, that is I. So hence we have inserted the node I into the array. The next step is to insert the root node. So E is the root node for the subtree of E and I. So E will be inserted into the array next. And hence we have inserted E into the array. Now finally, for the subtree of D, we will be inserting the root node B, as the algorithm states, and hence we have inserted the node B into the array. Now as you can see, for the main root node A, we have traversed the entire left subtree. Now according to the algorithm, we need to move to the right subtree. Now going down to the right subtree, we can find that F has a subtree of its own. So we'll implement the algorithm on F as well. And first we'll insert the node J, since it is the leftmost node for the subtree F. So J is being inserted into the array. Next, as the algorithm states, we'll insert the right node of the right subtree. So K will be inserted into the array. Finally, the root node F for the subtree of F, J and K will be inserted into the array. Now moving one level further up, as we can see, C has no left child. So we'll directly insert F into the array. But as we have already inserted F into the array, we'll directly insert the root node C into the array. And hence we have inserted C into the array. And finally, now moving to the root node A, which is the last node left in the array, we'll insert A into the array, finally completing a post-order traversal algorithm. And here is the list or the path through which the post-order traversal has taken place. So it will be G, H, D, I, E, B, J, K, F, C and A. So this is the post-order traversal path for the tree given in an example. Now this might seem a bit difficult to you, but you will eventually gain speed and understand the concept better with practice. Take different examples and practice on the same, and you will gain speed as well as you will also understand the concept better. So now moving to the level order traversal. This is by far the easiest traversal algorithm of all. In level order traversal, all the nodes at a level are accessed before going to the next level. This algorithm is also called as the breadth-first traversal algorithm. So now we'll start the algorithm, and as the algorithm states, we'll move level by level. So we'll begin with the level 0, that is the root node. So since there is one root node in any tree, so since root node A will be the first node to be inserted into the array, and hence we have inserted A into the array. Next we will move to level 1, that is one step below the root node A, and move to the child nodes of A. Thus, since B and C are the child nodes of A, so we will insert B and C into the array. Now how should be the insertion position into the array? So we'll move from left to right, that is, first we will insert the node B into the array, then we will insert the node C into the array. Thus, anytime you move to a new level, the insertion position should be from left to right. Next, moving to level 2, here we have 3 nodes, basically 2 child nodes of B and 1 child node of C. So we'll again move from left to right, inserting the nodes B, then E, then F into the array. Finally moving to the leaf node level, which is the last level in the tree, and again moving from left to right, as you can see we have inserted G, H, I, G and K into the array, thus completing the level order traversal algorithm. So as you can see, this is very simple as compared to the previous 3 algorithms. You just need to move level by level and insert the nodes from left to right in any level. Thus, in order to gain speed and expertise in any traversal algorithm, you need to practice a lot. Before exam, you need to practice at least 5 to 10 sums of the same, so you will gain better understanding of how to perform tree traversal algorithm in the examination. Thank you. Please do like, share and subscribe to the video. If you have any questions or queries, you can post in us comments below and I'll be happy to answer the same. These are a few of the other videos from my channel. If you liked this video, you can watch these videos as well.